Okay, so welcome to Fundamentals of Academic Success, and I hope you're making satisfactory progress towards the end of this course. Today is Friday, July 21st, and you have your end of week check-in due today by 11:59 p.m. And the introduction to calculus post has also due today. So next week will mostly be reflection and the end of course or end of program reflection and orientation for the beginning of the fall 2023 semester. I'll be sending out some additional communications on next week's activities. Now, each student participating in this course is required to set up a one-on-one appointment sometime next week to discuss their progress and their participation in this course and the kickoff of the upcoming semester. So reach out to me by email and indicate which times or what time works best for you. And then I'll send you a calendar invitation with the virtual meeting link for next week.
I have a question.
Yes.
Since we're doing one-on-one meetings next week, are we still doing meetings Monday and Friday, Monday and Friday?
Yes.
Okay, thank you.
So Monday we will review. Today we're going to review some of the algebra, and Monday probably calculus, and then Friday will be like the closing session for the course. Any other questions? Okay. So I'm going to share the presentation link for the algebra review for today in the chat. So you can click on the link in the chat to join the class. And I'll give you a couple of minutes to join. The Rihanna is in. If you need help, let me know. Kaylin, do you need help joining the class, the presentation?
I'm trying. My phone's a little slow right now. I'm trying to join it off my phone and look at it on my laptop.
Okay. Jamaria, join the presentation using the link in the chat. So I'll go ahead and get started. So this is a review of rectangular coordinates. And the basic question we're trying to answer here is, how do we work with the Cartesian plane? And as you can see on this slide, the Cartesian plane consists of two axes, the x and y axis. The x-axis is horizontal, the y-axis is vertical, and both are perpendicular, meaning the two axes intersect at 90 degrees. So to represent the points on this Cartesian plane, so a point is just a set of two numbers representing the location of a point on the plane. So those two numbers that I used to represent the location is what we refer to as rectangular coordinates. Because if you draw, like, if you extend or extrapolate a horizontal line from the point to the y-axis, and then from the point to the x-axis, the shape formed is a rectangle. That's why they're called, rectangular coordinates. So the point -3, 2 simply signifies that to get to the blue dots, one would need to make 3 steps in the negative direction along the x-axis, and then the 2 steps upwards in the y direction. So the first coordinate is always the x coordinate, and then the second is the y coordinate. So the rectangular coordinate format is always something like this: the x, and then y, x comma y. So the first number that appears in the parentheses is your x coordinate, and then the second number is the y coordinate. And a little bit more about the axis. So all numbers starting from the origin where the two axes meet, going to the right, those numbers are positive. And then going up, also positive. And then any numbers going below the axis will constitute the negative y-axis. And then to the left, that constitutes the negative x-axis. And that conveys the notion of displacement. Displacement is, a quantity that not only specifies the amount of distance covered, but also in which direction. So the key parts of the Cartesian plane, which I mentioned in the previous slide, is the origin. So where the two axes, x and y, where the two axes cross or meet, is called the origin, and is designated by the number 0. And then all numbers from there going to the right are positive. And you could call that the positive x-axis. And then all numbers starting from the origin going to the left will be negative. And that is often, referred to as the negative x-axis. Going up, positive x-axis, and then going down, negative y-axis. So remember that horizontal comes from the word horizon, like what you see when you look outside. The y-axis is vertical, straight up and down, and the origin is the point 0, 0. So 0 on the x-axis and 0 on the y-axis, basically where the two axes intersect. And feel free to pause and ask questions as we continue this discussion. It's not meant to be, a one-way transfer of information. It's important that you understand everything as we go along. So if anything is not clear or making sense to you, feel free to unmute and ask a question or raise your hand. So another aspect of the Cartesian plane is the notion of quadrants. So if you took a circle and drew the XY plane on top of that circle, it would split the circle into 4 equal parts. So if the origin is centered on the circle, then it will split up the circle into 4 equal parts. Think of a pizza. So if you slice a pizza into 4 equal parts, so each part will be called a quadrant. So there are 4 quadrants in the Cartesian plane. The first quadrant starts from, if we go by angles, and assuming, I know you must have done some foundational work on trigonometry and are familiar that with the angular positions of this axis. So this is 0 degrees, this is 90 degrees. If we go counterclockwise, this is 180 degrees. This is 270 degrees. And then when you get back here, you have 360 degrees. So one full revolution is 360 degrees. So 0 and 360 coincide. So going from 0 to 90 degrees is the first quadrant, and then from 90 to 180, that's the second quadrant. From 180 to 270 is the third quadrant. And then from 270 to 360 is the fourth quadrant. Now, what you need to remember is that in the first quadrant, all X and Y values are positive. So any point located anywhere here in this quadrant is going to be represented by 2 positive coordinates. So for instance, the dot I just created, if I count from here, this is 1, 2, 3, 4, 5, 6, 7. So 7 points along X. And then to get to the dot, I have 1, 2, 3, 4, 5, 6, 7, 8 along the Y axis. So the coordinates of these dots will be 7, 8. And both will be positive. Now, in the second quadrant, all the X values, because the first coordinate is always X, so all the X coordinates are negative because all points in the second quadrant are to the left of the origin. And we know, we mentioned earlier that all points to the left of the origin will be negative along the x-axis. So this point marked here, for instance, has, if we count the coordinates, so this point maps to -8. However, all the y coordinates are positive because in the second quadrant, any point located in the second quadrant will be located above the origin when looking at the y-axis. So all points on the y-axis above the origin are positive. So again, if we extrapolate, draw a horizontal line, it maps to 5. So the coordinates of this point would be -8, comma, +5. So that's the coordinates for the point in the second quadrant. So essentially, any point in the when you're looking at rectangular coordinates, if you see a pair of values, the first one is negative, the second one is positive, then it must be located in the second quadrant. If both coordinates are positive, then it must be in the first quadrant. Now let's move on to the third quadrant. All the x values are negative, all the y values are negative, because anywhere in the third quadrant, you are located below the x-axis or below the origin, and also to the left of the origin. So the x and y coordinate will both be negative. And so let me pick a point somewhere here. Can somebody tell me the x coordinate for this point?
-9.
Okay, so -9, comma. What's the y coordinate?
Is that -7?
-7?
That's correct, -7. So all you need to do is put your ruler and draw a horizontal line here to get the y coordinate, which is -7 right here, and draw a vertical line upwards, and you get -9. Again, the order is x first, then y second. So -9, comma, -7. And then in the fourth quadrant, all x values are positive and all y values are negative. So if we pick this point right here, can somebody tell me the coordinates for this point?
+6, -9.
+6, -9. Okay. Any questions? No. Okay. So let's proceed. So even though this looks very trivial, and I'm sure you've seen this before, this information is extremely useful when you start analyzing graphs, or when you start taking physics courses and dealing with forces and so on. So yeah, you'll be required to analyze different forces acting on an object. Those forces are vectors, they have magnitude and direction, and you may need to resolve forces into x and y components and say and predict which direction the resultant force will act. So knowing the details of the coordinate system, the signs of the x and y coordinates in each quadrant is useful, because once you get your answer, If your answer comes out with two negative coordinates, then you know the quantity is located in the third quadrant. If it's a positive x, negative y, that's the fourth quadrant. Positive x, positive y, first quadrant. Negative x plus y, second quadrant. So let's watch this quick video on the Cartesian coordinates plane.
Important foundation for tons of math problems. In this lesson, we're going to learn something that's an important foundation for tons of math problems, including those you'll encounter while learning basic algebra. We're going to learn about graphing, which basically means taking mathematical relationships and turning them into pictures. Hey friends, welcome back to the joy of graphing. We're going to pick up right where we left off. We already have this nice, beautiful function right here, but it needs a friend. And we're going to do that by adding some points. So let's put the next point right here. Now all we need to do is connect those points, because they're all friends. And what do friends do? They stay connected. Oh, and look at that. That's beautiful. Well, not the kind of picture that you'd hang on your wall. Graphing just means making a visual representation of an equation or data set so you can understand it better. It's a way of helping you literally see how math works. When math is just a bunch of numbers and symbols on a page, it can be pretty abstract and hard to relate to. But graphing is like a window into the abstract world of math that helps us see it more clearly. In fact, the focus of our lesson today actually looks a bit like a window, and it's called the coordinate plane. The coordinate plane is the platform or stage that our graphing will take place on. But to understand how it works, we first need to start with its closest relative, the number line. You remember how a number line works, right? A number line starts at 0 and represents positive numbers as you move to the right and negative numbers as you move to the left. And there's usually marks showing where each integer is along the way. Now imagine cloning that number line and rotating the copy counterclockwise by 90 degrees so that the second number line is perpendicular to the first, and they intersect at their 0 points. What we have now is a number plane. It's basically like a two-dimensional version of a number line, but that second dimension makes it much more useful. With a simple one-dimensional number line, we could show where various numbers were located along that line by drawing or plotting points. But no matter how many points we plot, they're always on the same line. But with the two-dimensional number plane, we can plot points anywhere in that 2D area, and that opens up a whole new world of possibilities. With the one-dimensional number line, plotting points was easy. You just needed one number to tell you where to plot a point. But with the two-dimensional number plane, you actually need two numbers to plot each point. These two numbers are called coordinates because they're the same rank or order, and they work together to specify the location of a point on the number plane. In fact, that's why the number plane is often referred to as the coordinate plane. It's the stage for plotting coordinates. Coordinates use a special format to help you recognize them. The two numbers are put inside parentheses with a comma between them as a separator. So when you see 2, 5, or -7, 3, or 0, 1.5, you know you're dealing with coordinates. Okay, to understand how coordinates work, remember that our number plane is formed by combining two perpendicular number lines. From now on, we're going to refer to each one of these number lines as an axis. One of the axes is horizontal, like the horizon, which means the other axis is vertical, or straight up and down. And they're often called the horizontal and vertical axes because of that. But even more often, the axes are referred to by variable-based names. The horizontal axis is called the x-axis, and the vertical axis is called the y-axis. Why use variable names? Well, there's two good reasons. The first is that variable names are more flexible than horizontal and vertical, which relate to specific orientations in space that may not always be relevant. And the second reason is that each of the two coordinate numbers is actually a variable that relates to a specific position along one of the two axes of the coordinate plane. And since those variables are usually called x and y, it makes sense to name the two axes the same way. The first coordinate number listed will be called x, and the second coordinate number listed will be called y. And we're always going to list the numbers in that same order, x first and then y. so that we never get confused about which is which. In fact, coordinates are often called ordered pairs because they're a pair of numbers that are always listed in the same order. X value first, Y value second. So if you have the coordinates 3, 5, that means X equals 3 and Y equals 5. Pretty easy, right? But now, how do we actually plot these coordinates, or ordered pairs, on the coordinate plane? Well, the first number in the ordered pair tells you where along the x-axis the point is located. And the second number in the ordered pair tells you where along the y-axis the point is located. The two numbers in an ordered pair work together to define a single point. And each one of the numbers only gives you half of the information about where that point is. To see how this works, let's plot the coordinates 3, 2. First, we locate the x value along the x-axis, which is at 3 in this case. But instead of putting a point there, we draw, or just imagine, a line perpendicular to the x-axis that goes through the 3. We do that because the first number in the ordered pair only tells us where along the x-axis the point is, but it could be anywhere along the y-axis. We won't know that until we plot the second number. So temporarily, we just draw a line there to represent every possible point that could have an x value of 3. Next, we locate the y value along the y-axis, which is at 2 in this case. But again, instead of putting a point there, we draw or just imagine a line perpendicular to the y-axis that goes through the 2. We do that because the second number in the ordered pair only tells us where along the y-axis the point is, but it could be anywhere along the x-axis. So we just draw a line there to represent every possible point that could have a y value of 2. But look what we've got now. The first line represents all the possible locations where x equals 3. And the second line represents all the possible locations where y equals 2. And the exact point where the two lines intersect represents the only point in the entire coordinate plane where both x equals 3 and y equals 2. That intersection is the location of our point. Pretty cool, huh? And that's a really good way to understand how the coordinate plane works. But I want to show you an even easier and more intuitive way to actually plot points. This more intuitive way involves starting with a point at the origin of the coordinate plane and then treating the coordinates like a set of simple instructions that tell you how far to move your point in the x and y directions. For example, to plot the coordinates 3, 2 like before, we start by imagining a point at the origin, 0, 0. Then we look at the first number in our ordered pair to see how far we need to move our point in the x direction. Since x is positive 3, we move our point a distance of 3 units in the positive x direction. And then from there, since y is positive 2, we move our point a distance of 2 units in the positive y direction. So that's a pretty easy method for plotting points. Let's try it a few more times so you get the idea. Let's plot the coordinates -4, 3. Again, we start by imagining a point at the origin and then let the coordinates tell us how far to move it along the x and y axes. Since x is -4, we move the point a distance of 4 units, but this time in the negative x direction, which is to the left. And then, since y is positive 3, we move the point a distance of 3 units in the positive y direction. Now, let's plot the coordinates -3, -3. In this case, x and y are both negative, so starting with a point at 0, 0, we move it 3 units in the negative x direction and then 3 units in the negative y direction. And last, let's plot the coordinates 4, -2.5. Starting at 0, 0, we move the point 4 units in the positive x direction and then 2.5 units in the negative y direction. Okay, so we've plotted 4 ordered pairs the easy way. And did you notice that each of these points is located in a different region of the coordinate plane? These 4 regions are called quadrants, and their boundaries are defined by the 2 axes of the coordinate plane. The quadrants are named 1 through 4, so we can easily refer to them in conversations if we need to. Quadrant 1 is the upper right quadrant, and it contains all of the points where both the x and y values are positive. Quadrant 2 is the upper left, and it contains all of the points that have a negative x value and a positive y value. Quadrant 3 is the lower left, and it contains all of the points that have both a negative x and a negative y value. And quadrant 4 is the lower right, and it contains all of the points that have a positive x value and a negative y value. Roman numerals are usually used to label the 4 quadrants, and they're in that order because that's the order you would encounter the quadrants if you started with a line segment from the origin to the coordinate 1, 0, and then rotated that line counterclockwise around the origin. Doing this sweeps out a shape called a unit circle, which is divided into 4 quadrants, just like the coordinate plane. All right, so now you know what the coordinate plane is, and you know how to plot points on it. But you might be wondering, what has this got to do with basic algebra? Well, algebra involves many different types of equations and functions that are a lot easier to understand if we graph their solutions on the coordinate plane. And as you know, the way to really get good at math is to practice what you've learned by doing some exercise problems. Thanks for watching Math Antics, and I'll see you next time.
Any questions?
No, sir.
Okay, so let's proceed. So you're familiar with this theorem that relates the 3 sides of a right angle triangle. The long side is called the hypotenuse, and the square of that side equals the sum of the squares of the 2 perpendicular sides. You will encounter this equation or this formula a number of times in any situation that deals with 2 perpendicular vectors. They may ask to find the hypotenuse. And again, this has applications in forces and any vector quantity that you're going to study in any of your STEM courses. Now, using Pythagoras theorem, given any 2 sides of a triangle, you should be able to find the missing side. So for instance, in this case, could you find the missing side? Can somebody tell us how to find x if we know the other 2 sides are 8 and 4? Can somebody tell us how to find x?
You would do 8 squared minus 4 squared and then find the square root of that.
All right, perfect. So basically you start out with the theorem that says x squared plus 4 squared equals 8 squared. So basically the sum of the squares of the 2 perpendicular sides equals the square of the hypotenuse, which is 8. Now, since we know the hypotenuse 8, we know the other side, which is 4. To solve for the missing side, we just need to isolate it on one side. So if you subtract 4 squared from both sides, you have x squared equals 8 squared minus 4 squared. And then if you take the square root of both sides, you obtain x. So can you work out this problem? Okay, so can somebody explain how to get to the answer?
You just add up 7 squared plus 24 squared, and then you square root the answer.
Okay, so C equals square root of 7 squared plus 24 squared. Yeah. And some of you may have a challenge, maybe entering this into a calculator. That's another skill you need to learn. You need to practice. You need to know how to correctly enter numbers into a calculator. You need to understand how a calculator will execute mathematical operations when you enter a number. So 7 squared plus 24 squared, square root will give you the 25. So the next concept when dealing with the Cartesian plane or coordinate plane is the notion of distance. So when going from one point to the next, if you're traveling from here to Montgomery, you may want to know how far your destination is because it will determine how much time you need to get there. Maybe you have an appointment in Atlanta. Maybe you have a job interview somewhere or internship. So finding the distance between points is it has a practical application in everyday life. Now, the equation to calculate the distance between 2 points is shown on this screen, on this slide. So first you need to locate the X and Y coordinates of the 2 points and then subtract the X coordinates and then the Y coordinates, and then take the square of both differences and then the square root. And this is what your GPS will do when you enter your destination. And then it tells you, you know, you have 105 miles to get to your destination. So what it's simply doing is using satellite information through the satellite system that powers the GPS to calculate the distance between the coordinates of your starting point and the coordinates of your destination address. So even though you may enter a physical address, the GPS will convert that address into a pair of coordinates, X and Y, and then use that information to, you know, calculate the distance. And as you drive, the GPS system will continually recalculate, you know, the distance between your current coordinate and where you're going to tell you how far you have to go to reach your destination. And you can practice with these problems. Take a screenshot. Of course, you have this recording, so you can rewind and go back here to practice these problems, finding the distance between the 2 pairs of points. Remember, the first coordinate is X and the second coordinate is Y. Was anyone working out the problem?
Yes, sir. I was just too slow.
Okay.
Dang.
All right, so let's restart. Maybe I should have given more time because this requires a little bit more computation. So if your answer has 2 digits, you just enter the 2 digits in the boxes. Okay, so I'm going to move forward to the next. One minute before we advance, if you still haven't entered your answer. Okay, so let's see. Okay, so the distance between these 2 points is 13. So 16, or let's say 7 minus 2, that's 5 squared, that's 25, plus 16 minus 3, which is 13, 13 squared, and then the square root, it will give you 13. Again, just for information purposes, I'm going to skip over this, but you can review this. So you can verify the right triangles on Cartesian planes by computing the distance between the vertices of the triangles. Another useful point when dealing with Cartesian plane is the notion of midpoint. So sometimes you have a line segment and you're wondering where the midpoint is located. So it turns out there's a formula to determine the midpoint of any line segment. Simply add the x coordinates and divide by 2, and then the y coordinates divide by 2. The new coordinate point will be exactly midway between the ends of the line segment. Another concept is translation. So you can shift a point from any location on the Cartesian plane to another location. For instance, here, to shift or to translate the point A to the point A prime, notice the difference in coordinates. The x coordinate of A is 2. The x coordinate of A prime is what? What is the x coordinate of A prime? Can you hear me?
Did you say what is the difference between A and A prime?
No, what is the x coordinate of A prime?
6.
6. So how do you get from 2 to 6? What do you need? What operation do you need to perform on 2 to get 6?
Add 4.
Add 4. So yeah, and I should clarify that here we're going to restrict ourselves to addition and subtraction, no multiplication, no division. So you need to add 4 to 2 to get 6. And what do you need to do to 4 to get 2?
Subtract 2.
Subtract 2. So translating 2, 4 to a new point 6, 2 involves adding 4 to the x coordinate and subtracting 2 from the y coordinate. With that knowledge, how could you translate the point B with x coordinate of 1 and y coordinate of 2 to a point B prime with an x coordinate of 5 and a y coordinate of 0? Can somebody tell us?
Add 4 in the x direction and subtract 2 in the y.
Okay. So basically, if we add the ordered pair plus 4 and minus 2 to the point B, then we translate the point B to a new point called B prime. So again, take note of the concept of translation. Translation simply means moving points around the coordinate plane. So midpoint, we just studied the concept of midpoint. Can you compute the midpoint between 0, 8 and 2, negative 4?
I know the answer, but it's not letting me input it in, right?
Okay, just type it into the chat. Don't worry about it. So maybe I should have given more directions. So the first box is the first parenthesis, and then the first coordinate, then a comma, and then 2, and then the other parenthesis. That's why it had 4 boxes. Maybe you are trying to enter everything in one box, but this is the correct answer. 0 plus 2 divided by 2 gives you 1. 8 plus negative 4 is plus 4 divided by 2 gives you 2. So the midpoint connecting these two coordinates is the point 1, 2. And then when dealing with algebra, you may have to compute the area, the perimeter, that's the distance around a shape, the surface area, volume of different shapes. And this slide summarizes the formulas for the perimeter of a square, a rectangle, the circle, and then area of square, rectangle, triangle, trapezoid, circle, surface area of a cube, cylinder, cone, sphere, and then the volume of a cube, a cylinder, a cone, and sphere. You need to know this, maybe not memorize it, but not know them by memory, but know how to use this. If given this equation, you should know how to compute the area, the volume, and the perimeters of these different shapes. And we'll conclude our class with this. And remember how many inches are in 1 foot. That will help you compute your final answer. seconds. Responses. Your answer should be in cubic feet. To go ahead and stop this. Okay, so the correct answer is 3 cubic feet because the volume of a box is given by the length multiplied by the width and then multiplied by the height. However, we know that 12 inches equals 1 foot, so 6 inches is half a foot. So the volume is 3 times 2 times 1/2, which gives you 3. So 3 cubic feet. Now, the error that some of you might have made, or that many students will make, would be just to multiply these 3 numbers and say 3 times 2 times 6. What is wrong with that? What is wrong with just multiplying 3 by 2 and then 6?
One of them isn't in feet.
One of them isn't in feet. So when doing calculations, you have to make sure the units representing the same variable are the same. So for instance, you cannot perform a calculation where the time is in seconds and then another variable having time is in minutes. When you multiply seconds and minutes, what do you get? No answer. When you multiply apples by oranges, what do you get?
Apples and oranges?
Okay. Yeah, the short answer is it doesn't make sense, right? You cannot add apples and oranges. You cannot multiply apples by oranges. You have to get a result, you have to, the variables have to have the same units. So you can only add, let's say 5 apples to 2 apples to get 7 apples, but you cannot do the same with different, fruits. So remember that when doing algebra, when doing calculations in your science lab, all your measurements have to be uniform. And again, this is important because the device you may be using to record certain measurements may have different units. So you may measure one thing in inches, another one in centimeters, and so on. But when doing the calculations, it's your responsibility as a scientist to know that your result will not make sense if you mix, different units for the same quantity. So that is the end of our class today. Are there any questions?
No, sir.
Okay, so if there are no questions, then remember to complete any outstanding activity. The last day to make up anything you've missed is this weekend before Monday, before our review session on Monday. And then make sure to reach out and set up a one-on-one appointment to discuss your participation, your standing in this course and the upcoming fall semester. And then we will wrap up everything next Friday, and then look forward to seeing you here in person during